Okay, so today we're going to start a very long conversation about solving quadratics. We're just starting it today. So the whole chapter is on solving these quadratics. What the heck does that even mean? Okay, so let's recap the word quadratic. That is just for a polynomial that is of degree 2. So you spent the whole last chapter factoring quadratics for the most part. Like x squared plus 3x plus 2. That's a quadratic, right? Because the highest exponent I have is to the second. So remember you factored it? You found factors of 2 that have to be 3? Right? This was like 2 days ago, so we haven't forgotten that much yet, have we? So factors of 2 that add to be 3, 2, and 1. And that's as far as we went in the last chapter, and we were happy with that. Okay? So let me explain now what's going on here. If you take a quadratic like this one, and you graph it, so I now turn it into a graphable equation on the coordinate plane. So now I'm going to write it as y equals this whole thing. Anytime you graph a quadratic, they all have the same shape. Do you know what that shape is?
A parabola.
Yes, a parabola. So, when you graph, oh yeah, when you graph, not today, but in this chapter, absolutely. When you graph a quadratic, they will form a parabola. So, new vocab word or old vocab word that you forgot about and are remembering today, I don't know. Parabola. And parabola is just a fancy word for a U-shaped graph. And we're going to talk about the characteristics of a parabola. So, in other words, a U-shaped graph. Okay, we're going to get more into the details of graphing them in a bit, but let's just take a look at some of the basic things that happen. So I'm going to have a U-shaped graph, right? The U is going to be perfectly symmetrical. So if you draw a dotted line down the middle, the two halves should be exact copies of each other if you folded them together. Okay, so in fact, this line, we call it the axis of symmetry. So it's perfectly symmetrical over that line, okay? And then you have the lowest point on the graph, or the highest if it's upside down. Do you remember what that one point is called? Vertex, yeah. That is called the vertex. Okay, so there's a little bit of background about a quadratic. When you graph them, they all have a U shape. So some are going to be, I call them up like a cup. Some will be down like a frown if it's flipped upside down. They will never look like C's, though, or the other way. Not if you would have to have y squared instead. So we're never going to have that. Those aren't going to be functions. We're not dealing with that in Algebra 1, okay? So it'll always be a U shape or an upside down U shape like a frown. They can be wide or narrow, so you can have a very wide U or a very narrow U, but they're always going to be some kind of a U shape somewhere on your coordinate plane, okay? So, speaking of the coordinate plane, let's say I had a coordinate plane here, x, y axes, right? And then I was going to have a parabola on this set of coordinate planes. Your parabola, 3 things could happen. Most of the time, well, I shouldn't say that. Oftentimes, when you draw a parabola in the coordinate plane, and it looks something like this, it's going to cross the x-axis. How many times? How many times did this one cross the x-axis? Twice. those spots where it crosses the x-axis, whatever those values of x are, that's what we refer to as the solution to the quadratic. So when you solve a quadratic, you are actually finding where that quadratic crosses the x-axis. So these 2 points, let's see, where the parabola crosses the x-axis, now this is also a little confusing, it'll come into play later. We're going to keep referring to it as solutions, but you can also call it solutions, zeros, or roots. All of them are kind of interchangeable. We usually, for right now, we're going to just refer to them as solutions. The solutions, zeros, or roots of the quadratic. You can. So this whole chapter is basically how do you find those numbers? How do you find where the graph is crossing the x-axis? One of them is absolutely to use a graphing calculator and ask the graphing calculator, okay, here's my parabola, where did it cross the x-axis? So that's one thing we'll be doing. And then there are 3 other methods. And I know you might be saying, oh, Miss Sabia, why would we have to learn now 4 different ways, graphing calculator, and 3 other different ways? Well, I'll tell you what. You're going to apply a different method based on the quadratic you have in front of you. Like if I saw, well, the ones that we're going to do today, I would absolutely use the method that we're going to use today because it's the easiest one. So I wouldn't use one of the harder methods on an easy quadratic. But you need the hard methods because some of them you can't use the easy methods on. You'll see as we go through, okay? So anyway, where the parabola crosses the x-axis is called the solutions, zeros, or roots of the quadratic. So that's what we're looking for in this chapter. Let me ask you this question. Will a parabola always cross the x-axis twice? No. What else could happen? So you're going to draw a U shape on the coordinate plane. Will it always cross the x-axis twice like it does in this drawing?
If it's an upside down U. Oh, sometimes it doesn't pass it at all, right?
Correct. You could have a situation where it doesn't cross at all. So let's say I had another XY plane. You could have a parabola like this that's just up above the x-axis. These 2 sides are going up forever. They're never going to come back down. I'm never going to cross the x-axis here. So some quadratics have no solution. Same thing, it could be upside down and it could just be, too far down. Right? Those are just going to keep going down forever. It'll never cross the x-axis. So it is possible to have no solution for a quadratic. So these have no solution. This one, my original one that I drew, that one has 2 solutions, right? Because it crossed 2 times. 2 solutions. Could I ever have more than 2 solutions? Let me ask you that. Could a single parabola ever cross the x-axis more than twice? No. So 2 is the most I could have. So I can either have 2 or I can have none, or is there any other possibility? Think on that while I answer this call. Good morning, Miss Sabia. Oh, did I not do my attendance? Oh, I did do it? No, I didn't. Shoot, I thought this was what you're calling about. Okay, yeah, I gotta do it. Yes. Thank you. Bye. Kaylee C., you're being dismissed, and I never took attendance. Shoot. Well, real quick, what's my third scenario, or is there one?
There isn't, because you said we can have C shapes.
That's true.
We have like diagonal parabolas?
No. But there is a third scenario. Can anybody think of a third scenario?
Oh, if there's a vertex on that.
Yes. What happens if your vertex happens to just be, it just touches the x-axis? So, like this, perhaps. Your bloop. So there are certain scenarios, like this one, where you only have one solution. The vertex is on the x-axis. Okay, so there's the three different possibilities. I can never have more than two solutions. I could have one if the vertex happens to be exactly on the x-axis, or I could have none at all. So those are the three things that are possible to happen. Okay, so I mentioned we're going to go through a bunch of different ways to solve quadratics. Today we're going to talk about the first way, the easiest way, but you can only do it in certain circumstances. So this way is called solving a quadratic by square rooting. Okay, so when can you solve by square rooting? Because I told you you can't do it all the time. Well, here's what has to happen. To use this method, B must be 0. Remember A, B, and C? Right? Yeah, A, B, and C. So the value of B has to be 0. So for example, okay, the other thing is, remember, these are now going to be graphable equations. So I'm going to have y equals something, usually. So let's say I had y equals, oh, I don't know, how about, let's just do something easy. 2x squared minus 8. So A is always the number in front of the x squared. So A is 2. B was the number in front of the x. Well, I don't have just an x. And then C was the number on the end. So in this case, B is 0. There is no x term. I have an x squared and I have a constant. So as long as I don't have an x squared and an x, do you get what I'm saying? Like if you look back at this one, see how this one had an x squared and an x term? If I wanted to solve this quadratic, I could not use square rooting. All I can have is just an x squared. I can't have the x with it. Does that make sense so far? Yeah, you with me? Okay. So in order to solve this, it's actually very easy. Let me ask you this question. What's the value of y at that spot right there? I don't know what x is, but what's y? It's 0, right? If you were to give me the ordered pair, it's going to be, I don't know what x is, I don't know, say it's 4. It would be 4 comma 0 because I didn't go up or down at all, right? So the value of y, wherever I cross the x-axis, will always be 0. So because of that, I'm going to, if there is a y in my equation, I'm going to replace it with a 0. Sometimes it's already done for you, so that's going to be step 1. Replace y with 0. Because I'm trying to look for what is the x value when y is 0. So I'm allowed to do this. Again, sometimes that'll already be done for you, but if it's not, any y's, just change them into a 0. And now, guys, it's almost what you were just doing when you were doing the Pythagorean theorem problems. I just want to get the x squared by itself, and then take the square root of both sides. So step 2 is get the x squared alone. What's the fancy way of saying that? Do you guys remember what's that fancy math word that means to get a value alone? Starts with an I. Someone said it. Isolate, yeah. Isolate the x squared. So how would I get x squared by itself? You'd add 8, yeah. Add 8 to both sides. And then divide it by 2. You got it. And I get 4 equals x squared. Now, I'm almost there. I want x, though, not x squared. So how would I get that? Take the square root of both sides. Now, here's where things get interesting, and you need to make sure that you remember this. When I take the square root of both sides, the square root of x squared is just x. The square root of 4
Don't you do that to us. This is child.
Well, it's true that 2 times 2 is 4,
Yes, so the square root of 4 is 2. Just write 2 and let us be over with.
but that's not the only answer, Bridget.
Negative 2.
Yeah. You need to take both roots. So, when we were just doing the, where did it go now? The Pythagorean theorem sheet. You were solving, let's see, here it is. You were solving for a side of a triangle. Can a side of a triangle be negative?
Yeah.
No. They're actual lengths, right? You can't draw a triangle with a -3 side, right? So here, I always just took the positive root because I can't have a negative side of a triangle. But can't I cross the x-axis in the negative direction? Right? Couldn't I have, look, doesn't it do it right here? This parabola crosses the x-axis where x is negative. So I can have negative x values here. So I need to worry about both roots. So the square root of 4 is 2, but it's also -2. So I want both answers. This parabola, if I were to graph it, is going to cross the x-axis twice. Once at +2 and once at -2. Okay, so take the square root of both sides and let's put a big star to say make sure you take both the positive and negative root. Because they're both answers. And you guys know this symbol, right? How I wrote in front of the 2 plus minus? That's just a way, instead of writing it a +2 and then a -2, you can write +-2, and that stands for both of them, if you weren't familiar with that. Okay? But if you only write 2, that's incorrect, and that's a totally different graph. That's a graph that only the vertex is just hitting the x-axis at 2. This one is crossing at -2 and at +2. Very different. Okay, so just always make sure you take both roots. Anytime you are solving a quadratic, we're taking both roots. Unless, I mean, in the future when we do some word problems, we might have to decide, okay, well, which root do we need? But here, I need them both. Okay? But the steps are pretty easy once you get the hang of it. You're just going to solve for x squared and then take the square root of both sides. So let's try one more. What if you had something like, oh boy, how about y equals x squared minus, I don't know, 36. So what are you going to do first? Yep, instead of a y, I'm going to have a 0. And then you're going to Add 36 to both sides. So now I have 36 equals x squared. And now you're gonna, yeah, I take the square root of both sides. The square root of 36 is positive and negative 6. There they are. So this one's going to cross a positive negative 6. Okay, one more. What if you had something like y equals 3x squared minus, I don't know, 72? How'd we do? What do you do first? I already did the 0. Now what? Add 72. Right. I'm trying to get the x squared by itself. So now I have 72 equals 3x squared, and then you would divide by 3. I think that comes out to be 24, right? Now what? Square root both sides. Uh-oh, this one's not a perfect square. So you are going to find the largest perfect square that goes into it, which is 4. Yep. So this one would split into the square root of 4 and the square root of 6. So that's going to come out to be 2 root 6 equals x, but what do I have to remember? Positive, negative. And that's pretty much it. So, let's just recap. When you graph a quadratic, what do they look like? Parabolas. And that's just a fancy way for saying a U-shape. How many times could that U-shape cross the x-axis? 2, 1, or not at all. There's 3 scenarios. Oh, how would it look like, let me just ask you this. Yeah, let's do one of these real quick. What if I gave you this one? Pretend it said y equals, but we will replace it with a 0. X squared plus, I don't know, 49. Right, so you already replaced the y with a 0. Now you're going to get the x squared by itself. So we'll minus 49 to both sides. I get negative 49 equals x squared. Well, you run into a snag here, because what's the square root of negative 49? Well, it's not negative 7, because negative 7 times negative 7 is positive 49. And I want negative 49. Uh-oh. Can you take the square root of a negative number? No, not until algebra 2. So, when you end up with something like this, there's no solution to this. It's never going to cross the x-axis. Can't take square root of a negative. Well, you can't take the square root of a negative in the real number system. So in Algebra 2, you will learn about a new number system, and then we'll do it. But I'll wait till then. Interesting, interesting. And so there's an example of a time that's never going to cross the x-axis. The other ones that we did are going to cross twice. Once in the positive, once in the negative. What might it look like if it is right on the x-axis? Well, let's see if I can probably fit it right here. What if you had something like this? How about y equals x minus 3 squared? Something like that. So I'm still going to replace the y with a 0. This time it's a little bit different though. I don't just have an x squared, I have this whole thing being squared. But as long as I get the thing being squared all by itself, I can still take the square root of both sides. So check this out. If I take the square root of this whole side and the square root of this whole side, what's the square root of 0? 0. And what am I going to get over here?
X plus 1.
Oh. You guys are thinking too hard, Danielle.
X minus 1.
You guys are close.
X squared.
A square root will cancel out a squared. Right? So those two cancel each other out. Square root of the squared, so I'm just left with what's underneath. Do you see that? Is that okay with everybody? So when I square root something that's being squared, they cancel out. I'm just left with what's underneath. And then all that's left to do to solve for x is add 3 to the other side. So in this case, I only get one answer for x. This is a time when the vertex would be on the x-axis. I only got one answer. So there, I mean, the square root of 0, you could say positive, negative 0, but it doesn't matter. There really isn't a positive, negative 0. If you said positive 0 plus 3 and negative 0 plus 3, don't you still get 3? Either way? Follow me? You with me? Maybe? A little bit? So this guy would only have one solution. So there's basically your 3 scenarios. Either you're going to have 2 solutions, which is most common. So normally you just solve it like we have been, and you're going to take positive, negative roots. So usually we get 2 solutions. Occasionally you'll get 1 solution. And then sometimes if you end up taking the square root of a negative, you have no solution at all, which means that that parabola will never cross the x-axis. All right. We're okay? All right.